Good day, students. Welcome to mathconserve.com. In this clip, we're going to be going over problems 33 to 35 of the Algebra 1 Common Core Regents exam for June 2016. All right, let's take a look at question 33. It says the height h in feet of an object dropped from the top of a building after t seconds is given by the function h of t equals negative 16t squared plus 144. Question: how many feet did the object fall between 1 and 2 seconds after it dropped? Okay, so the feet that it dropped between 1 and 2 seconds is basically the difference, the change in height. So what we have is, all right, so what we have here, let me give you a visual. So let's say this is the height from the ground, okay? And then the object is falling. Of course, from the top of the building to the ground. And let's just put an arrow. This is the what is actually falling, the object, okay? At a particular point in time, 1 second after the fall, it was a particular height from the ground, okay? And that height is basically the height when t is equal to 1. So that basically tells you that the height is going to be what? The height is going to be h of 1. Well, we're going to use uppercase letter here. So the height is going to be h of 1. Now, how do we know that the height is h of 1? Well, at any point in time, the height of the object from the ground is h of t. All right, so at any time t, h of t will be the height of the object from the ground. So at t equals 1, the height is going to be h of 1 because t is equal to 1. Okay? Now, later on, 2 seconds later, what's happening with the object? It's closer to the ground, right? Because it's falling. All right, so somewhere here, it's not drawn to scale. At this point in time, we have t equals 2. Okay? And it's a certain height from the ground. So this is t equals 2. Guess what the height is? The height is simply what you would get when you evaluate the height at t equals 2, h of 2. Okay, height at t is h of t, height at 1 is h of 1, and height at 2 is h of 2. Okay, now the question is asking how many feet did the object fall between 1 and 2 seconds. So what we're looking for in this problem is the difference between this height right here, h of 1, and this height right here, h of 2. What is that distance? That's what we're looking for, okay? So let me show you what I'm talking about. So here is the how many feet it fell. So this is what we're looking for, okay? All right. Now to compute this, how we're going to figure out what this is? Well, the height at h equals 1 is h of 1. Height at h equals 2 is h equals 2. So basically, the number of feet it fell between 1 and 2 seconds is equal to the difference in height. Okay, difference in height from t equals 1 to t equals 2. Okay, so this height minus this height will give you this remaining height right here. So that's basically h of, the bigger one is h of 1 because it's higher at t equals 1 minus h of 2. All right, so that's what this is. That's what we're looking for. H of 1, the top part, the top height minus h of 2. You're taking this bottom height from this one and you're going to be left with this portion right here. Okay, now the rest is going to be calculator work since we already have the function h of t is equal to negative 16t squared plus 144. So what are we going to do? What is h of 1? H of 1 represents the height of the object from the ground at t equals 1. You calculate that by plugging in 1 into your quadratic function. Okay, so that's basically how it's going to look. And you can plug this into your calculator, and then when you plug this into your calculator, or you just do it by hand, this is 144 minus 16, you end up with 128. And the unit is in feet. Okay, so this entire height right here, this is 128. What are we going to find next? We want to find that height 2 seconds later, h of 2, 2 seconds after it fell, it was dropped, or 1 second later. So that's going to be negative 16 times, instead of t, you're going to put in 2 as your input. All right, like that. You can plug this into your calculator. And then when you carry out this computation, negative 16 times 4 plus 144, you have 64 minus 144, which is 80 feet. Okay, so this height right here is 80 feet. Now, can you see how much distance it traveled from t equals 1 to t equals 2? It's simply 128 minus 80, right? So hopefully that makes sense. So let's go ahead and write that down. So we're going to do h of 1 minus h of 2 is equal to 128 minus 80, which is equal to 48 feet. Okay, so let's write down our answer in a sentence, although the problem doesn't ask for it, but let's just write it down so that you understand exactly what we just found. Okay, so the object fell 48 feet between 1 and 2 seconds after it was dropped. All right, so this little distance that we couldn't find here is actually 80 feet. No, sorry, 48. Hope I didn't put 8 in my answer. 48 feet is the difference in height. Okay, now let's go ahead and take a look at the second part of question 33. It says determine algebraically how many seconds it will take for the object to reach the ground. When the object is on the ground, how far is it from the ground? 0 feet from the ground, right? So what we're actually asked to do here is we're being asked to solve h of t when it is equal to 0 for t. Okay, it says how many seconds you're looking for a particular time value, right? So how many seconds does it take for the object to reach the ground? When the object is on the ground, the height is equal to 0. Okay, so all we simply do is we know what h of t is. H of t is equal to negative 16t squared plus 144. Okay, so what do we do with this? We set it equal to 0. And guess what? We have a quadratic function, ladies and gentlemen. I'm sorry, a quadratic equation. All right, this was a quadratic function. Now this is a quadratic equation. We can solve this using the quadratic formula, factoring. We can use completing the square. But if you take a look at this, you have only one term with a variable. So we can just use the square root property to solve this equation with ease. Okay, that's the fastest way. Okay, so to do that, I'll just simply subtract 144 from both sides. And then you have negative 16t squared equals negative 144. This is the best method whenever b is equal to 0, okay, using the square property. Now, divide both sides by the coefficient of the variable term, which is negative 16. And that yields t squared equals slash and dash, which becomes positive. 16 times 16 goes into 144 9 times. You can divide that out with your calculator or just use GCFs to reduce it systematically. And then to get t by itself, t squared equals 9. To get t by itself, you take the square root of both sides. And then you have t is equal to plus or minus 3. Anytime you take the square root of a square, you have to introduce plus or minus, since when you square negative and positive, you get the same square. Okay, positive square. So can time be negative? There's no way to travel back in time, so there's no such thing as a negative time. So since time t is always positive, the only answer we're going to keep is t equals 3 seconds. Okay, so this is how long it takes for the object to hit the ground. All right, let's take a look at question 34. It says the sum of two numbers, x and y, is more than 8. When you double x and add it to y, the sum is less than 14. Graph the inequalities that represent this scenario on the set of axes below. Okay, so part one is to graph a system of linear inequalities. So let's take a look at the two equations. So equation one, we're going to do that one in green. The sum is more than 8. So we know what inequality more than represents. More than is greater than. Okay, there's no equal there. It's more than. Sum operation is sign. It's plus. So the sum is more than 8. So we have x plus y is greater than 8. Okay? All right, so this is the first equation. Now, the second equation is tells us that when you double x and add it to y, the sum is less than 14. Okay, so less than, that inequality is just less than, and then we know addition is to add, is plus. Okay, all right, so there you go. So we're gonna graph both of them. All right, so let's start with equation one. Let's look at one, x plus y. Now, when you're graphing linear inequalities, you always want to put it in slope-intercept form because it helps you determine the right direction to shade. Okay, so let's go ahead and do that. We want to get y by itself. So we subtract x from both sides, and that yields y is greater than negative x plus 8. In order to graph the line, we need the slope and the y-intercept. Okay, so there's a 1 over 1 here. So the slope m is negative 1 over 1. So we're going to rise negative 1, which is a fall, and we're going to run 1. And our starting point on the y-axis, where you begin, is positive 8. Okay, that takes us to the second point that defines the line with this linear inequality. Since we have greater than, we're going to shade up. And since there's no line underneath, it's going to be broken. The line will be broken and you're going to be shading up. All right, let's go ahead and graph the green line, and then we will proceed to graph the blue line. All right, so set up our system, our coordinate system. All right, so let's see. We are going to start by, let me label my axis. This is y, this is x. We're going to start by graphing the y-intercept, 8, 1, 2, 3, 4, 5, 6, 7, 8. Bam. All right, put a point here. So you're going to rise negative 1 and run 1. Bam, that's 1 point. Could do another one. So this line right here basically defines the first line. So let's go ahead and graph that line for you. Something like, oops, change that. Okay, so there goes the first line. So it's broken and we're going to be shading greater than. So the direction of the shade will be upwards. Okay, so we're shading up. So put the arrow. The reason why I'm not shading right now is because we have two lines that we're going to be graphing, and I'll just use the arrows to find the exact quadrant that I will be shading. Okay, so don't shade there, just put the arrows. What this basically means is this entire region below the line should be ignored. Okay, the solution region is the set of points above this line, just for this one, okay? And then the other one will have its own condition, and then we just unite both of them together to find the solution region for the system of linear inequalities. Okay, so let's take a look at the second one. We have inequality 2. 2x plus y is less than 14. So for this one, we want to get y by itself. So we go ahead and subtract 2x on both sides. Subtract 2x, and you have y is less than negative 2x plus 14. All right, to graph this, we need the slope on the y-intercept. M is the coefficient of x, negative 2 over 1. So we're going to rise negative 2, which is a fall, and run 1. Rise over run for your slope. Your y-intercept, b, is 14. So these are the conditions to graph the 2 points that define our line. So let's go ahead and do it. Start from 14, so counting from 8, 9, 10, 11, 12, 13, 14. We're going to rise negative 2, 1, 2, and run 1. Okay, and then we're going to go ahead and graph our line. Okay, so there goes the line, and then we, let's see, we have less than, okay? So what does that mean? Since we just have less than, that means that you are going to shade down for less, shade down, and your line will be broken also, okay? Because we don't have a line of inclusion there. So since that line is not there, our line will be broken. What the breakage of the line basically means is that any point that falls on this line should be excluded. It is not included in the solution region. Okay, only the points that lay below this line are part of the solution region. Okay, so where is the answer to this system of linear inequalities? Let me make it a multiple choice. A, B, C, D. Where do you think the answer is? The answer is the region where both arrows are pointing to. If you look at A, only the green arrow is pointing to A, so that's a no-no. D, none of them are pointing there. C, only the blue arrow. Look at region B. What do you notice? Both arrows are pointing to this region, so guess what? That is our solution region, okay? The boundary points are excluded here, so just shade line here. Bam, 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 bam. So this is the graph of the scenario that represents the system of linear inequalities. This is 2x plus y, it's less than 14. And then this is the first equation, x plus y is greater than 8. Okay, now let's look at the second part of question 34. It says, Kai says that the point 62 is a solution to this system. Determine if he's correct and explain your reasoning. Okay, so all we just have to do is graph the point and see if it falls into the solution region. So let's graph the point. 6, 2, 1, 2, 3, 4, 5, 6, and 1, 2, bam. Okay, so this is what this Kai claims that this point is in the solution region. So what do you think? Is he correct or is he wrong? Well, Kai is wrong. Why? Because these two lines are broken, which indicates exclusion. Okay? Any point that falls on the line must be excluded from the solution region because the lines are broken. So let's go ahead and write it down. Kai is wrong because the point 62 falls on broken lines which represent points that should be excluded. Okay, there's a reason why it's broken. Broken or breakage means exclusion, which represent points that should be excluded from the solution region. Okay, To be specific, these are boundary points, okay? Boundary points that should be excluded. Boundary points, boundary points. So the boundary sometimes could be included, the boundary sometimes could be excluded. In order for the boundary to be included, that line must be solid, okay? And when you have intersection of a solid and a broken line, what you have is a scenario where it satisfies one, but it doesn't satisfy the other. So combining them as a system, it doesn't satisfy the system as a whole, just only one. Okay, so you need to have two solid lines in order for a point that falls on your intersection to be part of the solution region. In this case, you have a double violation. Both lines are broken. So the points that falls on those two broken lines is not a solution. It should be excluded. All right, so there goes your answer. All right, let's take a look at question 35. It says an airplane leaves New York City and heads towards Los Angeles. As it climbs, the plane gradually increases its speed until it reaches cruising altitude, at which it maintains a constant speed for several hours as long as it stays at cruising altitude. After flying for 32 minutes, the plane reaches cruising altitude and has flown 192 miles. After flying for a total of 92 minutes, the plane has flown a total of 762 miles. Question: determine the speed of the plane at cruising altitude in miles per minute. Okay, so first thing we want to do is write down the formula that relates distance, um, that relates a distance, rate, or speed and time formula. So the easy way to remember it is the DIRT formula, okay? DIRT. Distance equals rate times time. Rate is speed, okay? So distance is equal to speed times time. So that's the formula we're going to be using here. So let's take a look at what's happening. The whole scenario can be broken up into two parts. We have the cruising component and the climbing component, okay? So notice the first 32 minutes, it reaches its cruising altitude. So what was it doing that time? It was climbing. Okay, so it climbed for like 32 minutes, and then it covered 192 miles, and then it flew for another 92 minutes, which resulted in a coverage of 762 miles total. Okay, so let's give ourselves a visual so we can wrap our heads around what's going on. So we're not looking at altitude, we're just looking at how much distance it covered from its origin. Okay, so from its origin, it had to ascend to a cruising altitude. And then when it gets to its cruising altitude, it traveled for a certain period of time. Note, there's no mention of descending here, okay? So from 0 to 32, guess what? It covered a total distance of, how much distance did it cover? After flying 30 minutes? 192 miles. Okay, cool. So over here from 0 minutes to 32 minutes, it covered 192 miles. Okay, so here to here is 192 miles. Okay, and then from this, when it gets to its cruising altitude, okay, so when it reaches cruising altitude, after flying for 92 minutes, it has flown a total of 762 miles. Okay, so a total of 92 minutes. So starting from 0 all the way to here, we have a total of what? 92 minutes. Cruising and climbing. Okay, so this is climb right here, and this is cruise right here. Okay, so let's see. The question, and it also indicates that the plane has flown a total of 762 miles. So guess what? The distance from the starting position all the way, oh snap, my line is bending. So from here all the way to here, guess what? Is 762 miles. All right. So that goes just a visual of what's going on. So let me just go over what we have set up here again, so it's clear what's going on. When the plane takes off from 0 to 32 minutes, it was climbing the whole time. After climbing to its cruising altitude, right here, it had covered 192 miles, horizontal miles. All right. And then after 32 minutes, it traveled an additional period of time. And for a total of 92 minutes, it was just cruising at a constant speed. Okay, so from the start to the end, it covered a total of 762 miles. So the question is, determine the speed for this interval right here. What is the speed here? Okay, so in order to determine the speed, we know that distance is equal to speed times time. So do you know what speed is? Just simply solve this equation for s, t, divided by size by t. So speed is equal to distance over time. All right. Now, from 32 to 92, we need the distance and we need the time in order to calculate the speed. All right. So let's write it down. Distance from t equals 32 minutes to t equals 92 minutes. How much distance did it fly? The 192 to climb, the entire is 762, so the cruising is simply the difference, right? So it's going to be 762 minus, so cruising and climbing minus climbing. That will give us cruising. All right. So when you subtract these two, you're simply going to get 570 miles. I hope that makes sense. So this distance that you have right here, what's left is 570. Okay, 570 is your cruising distance. All right, now we have distance. What else do we need to create our speed? To generate our speed, we need time. All right, so time from t equals 32 to t equals 92. What's the time? Well, that's obvious. You just subtract these two times, right? 92 minus 32. Total time for cruising is 60 minutes. Okay? All right. Now, the formula for solving for speed is speed equals distance over time. Okay? Speed equals distance over time. If you solve the dirt formula for rates, you get this. So plug in the values that we have. Distance is 570 and the time is 60. Remember, our units is in miles per minute, right? So we have this set up right here. Okay, you just divide it with your calculator, you get 9.5 miles per minute. What is this? This is the cruising speed. The cruising speed of the aircraft, okay? 95 miles per minute. All right, let's look at the B part of the question 35. It says write an equation that represent the number of miles the plane has flown, y, during x minutes at cruising altitude only. So we are going to write down our formula again. What is our formula? Distance is dirt, right? Distance is equal to rate times time, but rate is speed. So you can write it as D equals ST. Okay. Now, in this problem, our distance is going to be our dependent variable. Okay, distance d is going to be y. Y as a function of x. Okay, our time t, guess what that's going to be? It says x minutes at cruising altitude only, so our time t is going to be x. Okay, so y miles for distance, x minutes for time spent cruising. Okay, now speed. What is the speed? Our speed s is the constant speed that the aircraft cruises at. Do you know what that speed is? Well, just look back to the previous question. That's the cruising speed right there, 9.5 miles per minute. Okay, so your speed is 9.5 miles per minute. So, well, in order to answer this question, the second part, you actually need an answer from the previous part, or else you can't do it. Okay, so let's rewrite the formula. Distance is equal to speed times time. All we're just going to do is plug in these values with y isolated. Okay, so d is y, speed is 9.5, and time is x. Okay, so our function for distance the plane cruises after x minutes of cruising is y equals 9.5 x. Okay, let's take a look at the third part of question 35. It says, assuming the plane maintains its speed at cruising altitude, determine the total number of miles, that's distance, the plane has flown 2 hours into the flight. Okay, so let's just draw a number line right here. So remember what happens with this plane. You have the cruising interval, which is, climbing interval, which is 32 minutes. Okay, so from 0 to 32, it's climbing. Do you know how much distance it covers here? Do you remember how much distance it's been climbing? Well, I have totally forgotten, so I need to go back and look at it. Okay, the total of 192 miles. Okay, so that's how much distance it's covered climbing. So then remember it's flying for 2 hours. Okay, so from 0 to 32, you've covered 192. So what's the distance left here? Okay, so this distance right here is our cruising distance. We don't know what that is. We have to find it. Okay, now the thing about cruising is we know the cruising speed, 9.5 miles per minute, and we know we can figure out the time. Okay, so the question is how much time is spent cruising? So cruising time is basically total time minus what? Minus climbing time. Yeah. Now we have to ensure that our units are consistent across the equation. We can have hours in one part of the equation and minutes somewhere else. We're told that the total flight time is 2 hours. So 2 hours is how many minutes? We have to convert this, okay? So it's 2 hours or 60 minutes in 60 minutes in an hour. So 2 hours is 120 minutes. Okay? All right, so that now our units will be consistent across the equation. Gotta be careful about that. So you have 120 minutes total time is equal, oh snap, I just did. Cruising time is what we are trying to find. So let's write it correctly. So cruising time is equal to total time, which is 120 minutes, minus the time spent climbing, which is 32. Okay, when you find the difference, you end up with 88 minutes. Okay, so we are going to have to find the cruising distance. Okay, so let's find cruising distance. Why are we looking for the cruising distance? Because we already know our climbing distance. Okay, Cruising distance plus climbing distance gives us the total distance, which is the answer to the question. All right, so to do this, we're going to use our nifty formula: distance equals rate times time. Rate is the speed, the cruising speed of the aircraft, which is 9.5 miles per minute. So 9.5 times, how much time did it spend cruising? 88 minutes. Okay, so 88 right here. So just put a side note. Time is 88, and our rate or speed for cruising is 9.5. Okay, so put this together, 9.5 times 88. Multiply that in your calculator, you get 836 miles. So total distance is what? Total distance is your climbing distance plus your cruising distance. That will give you your total distance. Okay, so let's put it together. Climbing distance, that we already know what that is, right? It's 192. Cruising distance is 836. When you add them all up together, you end up with 1,000. Just add it with your calculator, okay? 1,028 miles. 2 hours into the flight. Okay, let me just give you a visual. So climbing 192, cruising distance was 836. Ooh, wrong color. 836. So total distance is just the sum of these two. That's how we got 1,028 miles. Thank you so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful to you, give us a thumbs up. Your positive feedback is very important to us. Any questions or comments, just place it in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe for the remainder of this review series. More clips can be found on mathgotserved.com under test prep. Thanks again for watching, and have a wonderful day.